Hello students, this is Sir Murtaza from Al Murtaza School and welcome you to another lecture of physics. So let's start. Okay, before starting the lecture, I just want to say you something that it's been raining outside and I am here recording a lecture for you and hopefully you are also enjoying this monsoon weather season. So the rain is going outside but still we are here to learn to study. Okay, so as we are studying chapter number 2. So here we are continuing our next SLOs of chapter number 2. So first we will be looking onto the agenda for this lecture video. Okay, so what is the agenda? The agenda is in this lecture video, we will be talking about defined like and unlike parallel forces. It means that in this SLO, we will be talking about forces which are like and unlike. Okay, and in the second SLO, we will be learning about describe head to tail rule of vector addition of forces or vectors. Okay, so previously we have learned about vectors and we have seen that scalar quantities and vector quantities, these are two different quantities. So for vector quantities, the rules for addition is not the same as for the scalar quantities. We know that the scalar quantities, they usually follow the rule of arithmetic whenever we add or subtract a scalar quantity. But when we talk about vector quantities, the rules are not the same. The rules are different for the addition of vectors. Okay, so let's look on to our first SLO first. Okay, so here we will be talking about defined like and unlike parallel forces. So the definition of parallel forces is, okay, you have to just look onto the word parallel. Okay, you are definitely familiar with the word parallel. Just keep in mind and then look onto the definition of parallel forces. Okay, we are talking about forces. So forces which are parallel to each other are called, is called parallel forces. Okay, those forces which are parallel to each other, okay, this is something parallel to each other, are called parallel forces. Like the name defines parallel forces, the definition is same, those forces which are parallel to each other. And you know very well what are parallel or what are parallel lines. Those lines which do not intersect at a point are called parallel lines. Okay, how? Let's look on a figure. For example, I'm drawing a figure like this. Uh, this is a line, okay, and this is another line. Just assume that it is a very straight horizontal line. Okay, so these two lines are parallel. Why these two lines are parallel? Because if I extend it to some level, okay, for here I'm just extending it, it will never intersect each other. Okay, so those lines which are parallel to each other, it means that they do not intersect each other at a point when the lines are extended, are called parallel lines. Likewise, if I talk about non-parallel lines, okay, yeah, or you could say unparalleled. So for example, if I'm drawing a line like this, okay, again assume that this is a straight line, okay, little bit inclined, and again if I'm drawing a line like this, okay, these two lines are not parallel. Why these are not parallel? Because if I extend it to because if I extend it a little bit and extend it this a little bit, it will intersect at a point. Okay, getting the point? So those lines which do not intersect are called parallel, and those lines which intersect at a point are called non-parallel lines. Okay, so the definition of parallel forces are forces which are parallel to each other. Okay, so let's look on a little more further. So this is an example. Okay, let's suppose this is a box. Okay, and you are applying two forces on it. One force is 3 Newton and other force is 4 Newton. So as we are applying forces in parallel direction, so these forces are called parallel forces. Okay, now let's move on to the next definition. The next definition is like parallel forces. Okay, so here you have to look onto the word like. Like means same. Okay, so what is the definition? The definition is the forces which are parallel to each other and also have the same direction are called like parallel forces. Okay, again as the name defines, these are like parallel forces, so it should obey that these should be parallel and also they should have the same direction. Okay, so whenever the forces are parallel and they are in the same direction, so these are called like parallel forces. Okay, then okay, so here is an example. For example, this is you could say this is a shopper, okay, and we have put some apples on it, okay. And as we know, the weight is applying in the downward direction, and weight is a force, and force is a vector quantity. So all its direction is towards downward, okay. So here the weight of each apple is are like parallel forces, because all of these apples are acting their weight in the downward direction, and they are also parallel. So this is one example of like parallel forces. Okay. Now, unlike parallel forces, as a name defines, it should be unlike but parallel. What does it mean? It means that the forces which are parallel to each other but have direction opposite to each other. Okay. So here you have to emphasize on this word opposite, as it is unlike parallel forces, as it is parallel, so the forces should be parallel, and it is unlike means that it should have opposite direction. Okay, so the definition is the forces which are parallel to each other but have opposite direction are called unlike parallel forces. Okay, so here is an example. Okay, for example, there is a rod, okay, and you are applying two forces on it. One force is in the upward direction, which is F1, okay, and another force is in the downward direction, and it is F2. Okay, as these two forces are parallel, these are parallel, okay, but these are in opposite direction. One is applying in the upward direction and other is applying in the downward direction. So this is an example of unlike parallel forces. Okay, so let's now move a little more forward. Okay, so now we are done with our first SLO, like and unlike parallel forces. Now we will be talking about describe head to tail rule of vector addition of forces. As I have said, vector addition is not the same as the scalar quantities addition. It obeys a special rule. This rule for vector addition is called head to tail. Okay, this is head to tail rule. Okay, so what is the head to tail rule? Force is a vector quantity. It has both magnitude and direction. We know it very well. Therefore, forces are not added by ordinary arithmetic rules, as I have mentioned before. Okay, it is not added by ordinary arithmetic rules. Okay, now when forces are added, we get a resultant vector or a resultant force. Okay, here I'm talking about forces. Okay, I'm taking an example of force, as force is a vector quantity. So we will be looking vector addition with the help of the example of forces. Okay, so when forces are added, we get a resultant force. Okay. Now, what is a resultant force? The resultant force is a single force that has the same effect as the combined effect of all the forces to be added. Okay. It is very easy. For example, if you are pushing a car, okay, and you are applying two forces on it. So, for example, one force you are applying it with your right hand. That is, for example, you are not moving a car, you are moving something. For example, you have a suitcase and you are pulling it. Okay, so one force, for example, your right hand force is 5 Newton and your left hand force is, for example, 4 Newton. Okay, so the combined effect of both these forces are called the resultant force. Okay, so this is called as the resultant force, which is the combined effect of all the forces acting on a body. Okay, now, one of the methods for the addition of forces is a graphical method. In this method, forces can be added by head to tail rule of vector addition. Okay, so one method of adding forces is head to tail rule of vector addition. Okay, here there are two words, head and tail. I've told you before, a force can be represented by an arrow. So for example, this is a force which is represented by an arrow. This is called as the tail. Okay, this is the tail, and this is the head. Okay, for a vector, what is the head and what is the tail? The arrow, where the arrow is the head and its opposite point is the tail. Okay, so these are 2 points, head and tail. Head is the forward point and tail is the backward point. Okay, or you could say that tail is the initial point and head is the its second point. Okay, so this is head to tail. Okay, now we will look onto the head to tail rule of vector addition. Okay, now head to tail rule. What does this rule says? According to this rule, the head of the first vector is joined with the tail of the second vector. Okay. Then for resultant vector, the tail of the first vector is joined with the head of the last vector. Okay. So you just have to remember whenever you are adding vectors by graphical method or by head to tail rule, what you have to do, for example, you have two vectors. One vector is like this. So what you have to do, you have to add the second vector with its tail. Okay, as it has said here, according to this rule, the head of the first vector, the head of the first vector is joined with the tail of the second vector. Okay, and for the resultant vector it is opposite. What is it? The tail of the first vector is joined with the head of the last vector. How? We will see in this diagram. For example, this is a diagram. In this diagram, there are two vectors. One is vector A and one is vector B. Okay. Vector A is in horizontal direction and vector B is been inclined at some angle. Okay. So what I have done, this is our first vector. This is our second vector. So what I have done, I have joined the head of the first vector with the tail of the second vector. Okay, the head of the first vector is joined with the tail of the second vector, and for the resultant vector, this is the resultant vector. What we have to do, we have to join the tail of the first vector with the head of the last vector. So in this way, we add vectors by head to tail rule. Very simple, as the name defines, head to tail. The head of the first vector to the tail of the second vector. Okay, and for the resultant vector, the tail of the first vector to the head of the last vector. Okay, so this is head to tail rule. Now we will look onto our one example and see how this head to tail rule is done practically. Okay, so now we shall understand it with the help of an example question. Now there is a question. For example, find the resultant of three forces: 12 Newton along x-axis, 8 Newton making an angle of 45 degree with x-axis, and 8 Newton along y-axis. So here you can look to one thing, that whenever I'm talking about forces, there are three forces. One force has a magnitude 12 Newton and also its direction has been mentioned. Okay, so direction is important for a vector. And for the second vector, its magnitude is 8 Newton and it is making an angle of 45 degree with the x-axis. It is its direction. And 8 Newton is the third vector's magnitude and its direction is along y-axis. Okay, so there are three forces along with its direction which is being given to you. So as it is a numerical question, we will be doing some solution. So in the solution, first I have mentioned all the forces. I have named the first force F1, which is 12 Newton along x-axis. Second is F2, 8 Newton along 45 degree with x-axis. And F3, 8 Newton along y-axis. Okay. And one thing I have done is, as it is a graphical method, so I have decided a scale. Okay. Whenever you draw a graph, you set a scale. So here the scale is 1 centimeter is equal to 2 Newton. Okay, so whenever I draw a line of 1 centimeter, it means that I am representing 2 Newton's magnitude. And for example, if I draw a line of 3 centimeter, it means that it is representing 6 Newtons. Okay, as 1 centimeter is 2 Newton, then 2 centimeters should be 4 and 3 centimeters should be 6. Okay, now in this figure, you could see that first you should be very well aware of this, that what is x-axis, what is y-axis. Okay, so this is positive x-axis, this is positive y-axis, this is negative x-axis, and this is negative y-axis. So for the first force, which is 12 Newton along x-axis, this is the first force. 8 Newton for making 45 degree angle. This is the second force. And third force, which is F3 along y-axis, this is the third force. So I have added it by graphical method. Here you could see that this is the first force along x-axis. I have joined the second vector. How? The head of the first vector is joined with the tail of the second vector. Okay, this is the head of the first vector and this is the tail of the second vector. I have joined it. Then for the third vector, what I have done, I have joined the head of the second vector, because now for the third vector, this is the first vector. Second vector is the first vector for the third vector. So I have joined the head of the first vector with the tail of the second vector, which is F3. Okay. So, and for the resultant vector, what I have done, this is the first vector F1, this is the last vector F3. So I have joined the tail of the first vector with the head of the last vector. So in this way, I have added vectors by graphical method. Okay. Hope you have understood this. So what I have done, I will show you step by step in this slide. So the explanation for the diagram which I have drawn previously is, represent the forces by vectors f1, f2, f3 according to the scale given in the according to the scale in the given direction. Okay, what I have done, f1 was at x-axis, f2 was at 45 degree, f3 was at y-axis. I have set it according to the scale along with its direction. Then arrange these forces f1, f2 and f3. The tail of force f2 coincide with the head of force f1. Okay, the tail of second force f2 was coincide with the head of the first vector. Okay, that was head to tail rule. Similarly, the tail of f3 coincide with the head of the force f2. Okay, so here for f2 and f3, the tail of f3 was joined with the head of f2. Again, it was head to tail rule. Okay, then join point A, the tail of the force F1, and the point D, the head of the force F3. For what? To represent the resultant force. Okay. So let AD represent the force F. According to head to tail rule, force F represents the resultant force. So what I have shown previously, I have shown this step by step in this slide that what I have done. Okay, it is very simple. Hope you have understood is it is very simple. Whenever you are adding two or more than two vectors, just what you have to remember, you have to join the head of the first vector with the tail of the second vector. And for the resultant vector, what you have to do, you have to join the tail of the first vector with the head of the last vector. Okay, so this is it for this lecture video. Hope you have understood all the topics. So meet you very soon, inshallah, in the next video. So uh, till then, Allah Hafiz.